definitely come to my mind.
Okay. Okay. Morning, Matthew. Hurry, yes. Morning, Anthony. We're gonna go over that one together. Don't worry. What I'm looking for is 1 and 3. Yeah. Jonathan, I need that to be Sarah's desk, if you don't mind. Do you want to switch with her, or do you want to move to another seat? Where do you want to move to?
I mean, I can just switch them.
You sure? Okay. She sits way back there in the back. Is that okay? You sure? Okay. Thank you. Morning, Sarah. Morning, Ryan. What you need, baby? Yeah, that's fine. Yeah. Do you want to put it back behind my desk and I may messes with it? Okay. You're welcome. See you later. All right, guys, grab your bell ringers. We're going to work on 4 through 6 today. 4 through 6. All right, what about number 4? How do we do synthetic division?
So you have to do that 1 and then you move it to the left of the thing and write it as -1.
There you go. You change the sign. Yep, put it in this cute little box. All right, and am I missing any exponents?
X.
I'm missing an x, so I have 2 for x to the third, 1 for x to the second, 0 for the x, and 1 for my constant. Very good. All right, and then what do I do when I pull this 2 down? Do you multiply it, and then do I add these 2 or subtract these? You add. Very good. So 1 plus -2 is -1. Multiply, you get +1. Add, you get 1. Multiply, you get -1. Add, and you get 0. So this one's an easy one, right? Okay. So this is 2x to the second minus x plus 1. This one's a hard one. Divide by how much? 3. Very good. So this would be 2c to the third minus 17 over 3c to the second plus 2c plus 8 over 3 divided by c minus 4/3. Y'all okay? All right, what goes in the cute little box on this one?
Positive 4/3.
Positive 4/3. Very good. All right, let me make that look like a 4 instead of a 9. Am I missing any exponents? No. So I have 2 for c to the third, negative 17 over 3 for c squared, 2 for just my c, and 8 over 3 for my constant. Y'all okay? All right, bring down my 2. So if you need 2 on the side, this is 4/3 times 2 over 1, which is 8 over 3. Then looky there, they have the same denominator. So I go ahead and say negative 17 plus 8 is how much? Negative 9, but it's negative 9 over 3, which is negative 3. Then it's 4/3 times negative 3 over 1, which is negative 12 over 3, which is negative 4. Very good. Add those and you get negative 2. Look, I was nice to y'all. Looky there. 4/3 times negative 2 over 1 is negative 8 over 3. And it cancels. That wasn't a hard one. That was an easy one because I had a fraction. Alright, so let's see. 2c to the second minus 3c minus 2. That was easy because it had a, well, it wasn't easy. It was a medium problem, right? Who is that? Who is that? Oh, Max. I was like, who is that?
Miss Blackman.
Yes, dear.
Mackenzie texted me back. She said she should be here before the end of this period.
Oh, okay. Okay. Cool. I just want to make sure she was okay.
Yeah, I think she was sick.
Okay. What? Yeah, for right now, please. Is there an empty desk anywhere? Yeah, just right there. Okay, here we go. Evaluate using synthetic substitution. How in the world do we do synthetic substitution? We don't just plug in -4. That's not how we do synthetic substitution. That's just regular substitution. We do the cute little box with what inside? -4.
You do it the difficult way.
Set it up the same way.
Set it up the same way. There you go. I'm not missing anything.
Why is it -4 when you do positive?
Not with this one. This tells you exactly what you want to plug in. This is synthetic substitution. It's a little different. Alright, bring down the 1, multiply, add, multiply, add, multiply. Yep. Add, and you get. And what is my answer? -124 is my answer. Very good. So y'all are getting a little lazy on how you write your answers, okay? So f to the -4, excuse me, f of -4 equals -124, okay? Please make sure you're writing your answers correctly. Y'all okay? If you plugged it in, you will get the same exact answer. However, there is a reason we do synthetic substitution, and it is coming soon, okay? Yes, ma'am?
-4 times -30, or times 35 is -140.
Is it 140?
It's a -134.
There we go.
I plugged it in, and that's the answer I got.
Yeah, I just didn't add my 1 over when I multiplied. There we go. Sorry about that.
Miss Blackman?
Yes.
I use it back to me.
Quickly. Yes. Okay, so last night, guys, for some reason, my computer shut down after I left, so the ACT stuff didn't finish uploading before my computer shut down, which was weird. So get your ACT stuff out. I'm going to give you your answers and all that stuff, and you tell me which ones we need to go over. Your homework last night was to look at it, although I didn't get a lot of emails, so it kind of makes me wonder how many of you actually did your homework. So, anyway, but you get to slide a little bit because of a technical error. Alright, so I talked to the other pre-AP Algebra 2 teacher yesterday, and I was like, look, dude, I was like, how's about we don't do a quiz on Friday? How's about we just do some checkpoints, because it was several classes that were having issues with the roots that had something other than a square on it when we were rationalizing, and he said the same thing, that his kids were doing the same thing. So let's just do some checkpoints. We have 3 different checkpoints that we're going to do between now and Friday, and then we will have a quiz, but we won't have it on Friday like we had said, and it'll be a little bit more stuff in there. Yes, sir.
Can we go over number 2 for how to practice? Maybe go on to homework?
Yeah, we're going to. Yeah, we're going to go over all that. All right, I haven't checked homework or anything. We're going to go over all that. Don't worry. All right, first thing's the ACT. So what about number 11? Number 11, you should have gotten B. And number 12, you should have gotten K. Do I need to go over either one of those on 11 or 12? 11? Okay. Let's see. Ooh, it's been a minute since I've done these. Okay. Points B and C are line AD, and the length of AD is 30. So AD is 30. AC is 16. BD is 20. How many units long if it can be determined, is BC, this little piece right here. Okay, so we know the whole thing, sometimes it helps me to do this. The whole thing is 30. This piece is 16. Okay, so look, guys, if we know the whole piece is 30, and we know this piece is 16, then how can I figure out this piece right here?
14.
How'd you do that?
30 minus 16.
30, so CD is 30 minus 16, which is 14. So I know this piece is 14.
That's definitely 15.
Oh, golly, I just wrote 15. All right, so what else do we know? Let's see. What else did they tell us? They told us that BD was 20. So since I know this whole piece is 20, now that I know this is 14, what can I do to these two pieces to get this? Subtract. So BC is 20 minus 14, which is 6.
Wait, I thought you would have to like do 30 minus 20 to get the 10. Then you would subtract those answers to get the 4.
No. You do 30 minus 16 to get this missing piece over here. Then they, well, let me redraw it because it's a little crazy hot mess right now. So the whole piece was 30. Right? Whole piece was 30. This piece was 16. So these two pieces in 30, that means this piece is 14, right? Then they told me that B to D was 20. So if I know the whole thing is 20, then I just subtract the 2 to get this is 6.
Oh.
Sometimes it helps if you cover up with your finger instead of doing the lines like I did. All right, what about 12? Do I need to go over 12? Yes? Okay. So distribute the 8. So 12x is equal to negative 80 plus 8x. And then move the 8 over by subtracting. That would be 4x equals negative 80. Then divide, and x is negative 20. So it's a regular standard Algebra 1 problem. All right. What about on the back? 13 should have gotten E. Do I need to go over 13? Anybody need 13? Yes? Yes? Okay. So let's see. 13 should have gotten E. All right, have you ever seen the birthday cakes before that they're talking about when they have the cake is a little bit smaller than the actual board that it's sitting on? Y'all know what I'm talking about? Okay, so all it wants is the area, okay? This freaked you out because it had more than what you needed. It had this extra piece, which a lot of you were trying to probably do volume. It wants the area, so let's find the cake first. Area is length times width. The length is 16, and the width is 12. How much is that? 240 something, 192. Okay, then it wants the board. It told you the board sticks out how many inches on every side? 2. So that means the area of the board, or the box, whatever you want to call it, is 2 inches more than 16 right here, which is 18. 2 inches more on the other side, which would make it 20. The width is going to be 2 inches more on this side, which would make it 14. 2 inches more on this side would make it 16. Does that make sense to everybody? Then you just multiply those. That's 320. Well, that's the area of the whole box, right? How do I find the area of just the missing spot? You just subtract them. 18. There is no 18.
I don't know what I did, but I added to
one side.
Not the other
And then you add 2 to the other. What's that?
Okay, right here, 16. Because the board has to stick out on both sides, Brinkley.
You gotta add 2 inches each side.
If you got a question, speak up. I hear several of you asking, where did you get something from, and I can't hear you. Y'all okay? What? Yes, ma'am. Yes, okay. So it told you that the board is going to stick out 2 inches on every single side, right? So instead of 16, it's going to be 2 more inches in the front, which is 18, and 2 more inches in the back, which is 20. And then it's going to stick out 2 more inches on this side. So 2 more inches here would be 14. 2 more inches here would be 16. That's how I got to 16.
And why would they put the 3 there?
To show you how tall it was. That's part of the ACT, because you've got to realize that it's not wanting you to find volume, it's wanting you to find area. That's just part of the ACT part. All right, what about 14? Do I need to go over 14?
Sure.
Like, we ain't got time just to go over it because you want to. Do you need it? Okay. All right. If you need it, we'll go over it. All right, let's see. At the math club meeting, Principal Gonzalez cuts the entire cake into pieces. Each piece is 2 inches wide, 2 inches long, and 3 inches high. What is the number of pieces? Okay, well, this is volume right here. So let's find the volume of the cake, first of all. What's the volume of the cake? That's 3, times 16. Length times width times height. What was it, 12? So how much is that? Definitely not. Oh, sorry, Matthew. Sorry, Matthew. I thought you were meaning like it was 36. I'm sorry. I deserved that look. Okay, okay, let's see. How many pieces do we have? The pieces, so the volume of the pieces. Do you see how I'm labeling the volume like this to make it easier to see what the heck I got? So let's see. The volume of each piece is 2 wide, 2 long, and 3 high. So let's see, that's 4 times 3 is 12, okay? What is the number of pieces Principal Gonzalez cut the cake into? So in other words, how many,
You just divide them, right?
Divide, these two? Yeah, you just divide those two.
Probably 36.
So I guess they didn't put the 3 there just to throw you off, Grace. The first one, it kind of throws you off, but you do need it for the next one. A lot of times they really do put stuff in there just to throw you off. Or to make you think. They're not doing it to throw you off. What about 15? Do I need to go over 15? Okay. So let's see. The math club's going to pay $5. Ooh, I wouldn't even do it. I wouldn't even think about doing it for $5. Okay, so they're going to pay you $5 plus the cost of the cake mix, which is $1.73, plus the frosting, which is $2.67. And they're going to pay him sales tax. So I've got to add the sales tax. But first, before I can add sales tax, I have to figure out what it is. So to do sales tax, you multiply it by 5%, which is 0.05. There you go.
When you add the $5 in there?
Not yet. There's not a sales. Yep.
See, I would have never.
All right. So the sales tax is 22 cents, right? So then you take the $1.73 plus the $2.67. Not really. And 0 period, because we got to get through we got to get through the lesson today. We haven't started the lesson yet. So that's 440, right? So what is? Did I print? No, that's not 440. I didn't add the 22. That's not right. 462. That's right.
When you distribute the
And we got 0.22.
never mind.
All right, and now what do? We add the $5 because $5 doesn't have sales tax in it, and that's $9.62. All right. If you have a question, you should circle it and come see me when. 0 period. Okay. Okay. Now look, guys. If you're a junior, you are taking the ACT at school February 8th. April 8th, right? Isn't it April 8th?
That's wrong.
Isn't the 8th? Is it the 19th? It's somewhere. Hush. Stop it. It's somewhere early in April. Quit talking. Quit talking. It's somewhere early in April. It's like the 2nd week of April, somewhere around there, okay? We'll get more info later. I can't remember the exact date. So make sure that you are taking this ACT stuff seriously. If there's something you didn't understand, come see me during 0 period and we will discuss what problems you need to go over, okay? But right now, we have got to move on, okay? So here's what we're going to do. We've got to finish up a lesson today. So let's put our ACT stuff up. And let's go to page 21, the back of the page we were on yesterday, okay? I haven't forgot about your homework. What you got, Max? Yeah. I've already graded your test.
I wasn't finished with it.
You...
I was supposed to be here this morning.
Yeah, they have a number in front. What else? Okay, so they're just a square root. What do you notice that I can do to any of those numbers? Break which ones up, Sydney? Which numbers? 8 and 50. Perfect, because they're the ones that have the square roots, right? So what perfect square goes into 8? 4 times 2, right?
25.
And 25 goes into 50. 25 times 2. All right, here we go.
36.
So we're going to bring down this 4. We're going to take the square root of this 4. What's square root of 4?
2.
2. And we're going to leave that 2 inside. Then we're going to bring down the plus 3. We're going to take the square root of 25, which is 5, square root of 2, right? Y'all okay?
Yes.
All right. 4 times 2 is 8 square root of 2. 3 times 5 is 15 square root of 2.
Now you can add.
Why?
Because they have the same square root.
Because they have the same square roots, right? Same exact root, same exact number. 8 plus 15 is
36.
how much? 23 square root of 2. There you go. All right, number 2, here we go. 98. What perfect square goes into 98? Is that 49? Check it, make sure.
Yes.
49 times 2 minus, bring the 2 down in the front. 32, what perfect square goes into it? 16 times 2. Here we go. What's the square root of 49? 7 square root of 2. Bring down your minus 2. What's the square root of 16? 4. Very good. So times 4. Square root of 2. So that's 7 square root of 2 minus 8 square root of 2. 7 minus 8 is? Negative 1, or I can just say negative square root of 2, right?
Yes.
Okay, let's look at number 3. Zip it, come on. Alright, what do you notice? Which one? All of them. What goes into 12? 4 times 3. Bring down your plus 2. What goes into 27? 9 times 3. Very good. What goes into 128? Ooh.
How do you know what numbers to say?
The perfect squares.
64 times 2.
Perfect. Very good, Matthew. Oh, dang. They don't all have the same square roots. It's all right, though, right? Okay, so we have 5 times 2, square root of 3, plus 2 times 3, square root of 3, minus 8, square root of 2. Is anybody lost about where I got any of those numbers?
Is that the answer?
No. I didn't circle it. We're not done.
So you still add.
Where? The first one? Square root of 4 is 2.
Oh,
Yep.
I wouldn't have.
Okay, so 5 times 2 is 10. 2 times 3 is 6. What's the only set of numbers that I can combine? First 2, because they're the only ones that have the same square roots, right? They have square roots of 3. This one does not. So 6 plus 10 is 16 square root of 3 minus 8 square root of 2.
Well, you can't factor out.
You
the
could factor out an 8 if you wanted to. They don't normally do that, though, when they're different square roots. But sometimes they do. Sometimes they don't.
Okay.
All right, here we go. You just have to. It's one of those things you got to look and see what they give you. Ma'am? Sweet. That's not it. That's not algebra 2. This is algebra 1. We did this in algebra 1, okay? Nothing's new yet. You ready? Get it good? Okay, here we go. Number one. Now, multiplying, the rules are very loosey-goosey. You can pretty much do whatever you want to do, okay? So, what can I do first on number 1?
6 times 4.
What's 6 times 4? It's 20. Wait, they don't have the same square roots.
That's okay.
It don't matter. We're multiplying, right? There you go. We just multiplying. All right. When we in the inside is 8 times 2 is 16. Oh, wait a minute. When you multiply the bases, you add the exponents. 3 plus 1 is 4. C to the 4. And when I multiply the d, I add the exponents. So 5 plus 3 is 8. Now we can take square roots. What's the square root of 16? 4. So it's 24 times 4. I can take half of 4. Why am I taking half? Because this is the square root, right? 4 divided by 2 is 2. And what? This is square root.
No.
What?
I was just thinking about D.
D. What's wrong with it?
You can take 2 4s.
Yeah. So it'd be d to the 4. 8 divided by 2 is 4.
Oh.
It's divided by 2. All right. 24 times 4 is how much? 96. C to the second, d to the 4. All right, number 2, here we go. What do you notice that I can do first? Multiply 2 times 3. Oh my goodness, those have 4th roots. You better make sure you put the 4th root. Because I promise you, if you don't, when you get to the end, you're going to be wanting to take the square root instead of the 4th root. All right, and then I can do 8 times 2 because they're inside. That gives me 16. Then I got x to what power? The 8. And then I got y to what power? The 4th.
You divide that by 4.
I can, but first I got to do my numbers. Oh my goodness, how do I determine if 16 is a perfect 4th? 4 math 5. 16. Oh, it's 2. So we have, let's see, 6 times 2. X to the 8 divided by 4 is 2. Y to the 4 divided by 4 is 1. Then multiply and you get 12x squared y.
Well, that was good.
Y'all okay?
Yep.
Okay, only algebra 2 problem we've done so far today.
Are you for real?
Yes, I'm for real. Everything else on here is algebra 1. All right, here we go. Oh my goodness, what in the world is this?
Foil.
Foil, first, outer, inner, last. Here we go. First is 6 times 2 is 12. 3 times 5 is square root of 15. Y'all okay so far? All right, outer is 6 times 4 is 24. Square root of 3 times 2 is 6. Inner, negative 5 times 2 is negative 10, and then you just stick that square root on the back. Don't make it hard. All right, on the back, negative 5 times 4, negative 20, Grace, very good. And then just add that 2 onto the end. What? Now, do they have anything in common? Do they have anything you can break down? Do they have any perfect squares?
Wow, that's ugly.
It is a little ugly. They normally simplify a little bit better than that.
Wow, that's ugly.
All right, let's go to number 4. Oh my goodness. How do I know that it is foiling in the first place?
Because there's
All
4
it's a
monomials.
4 terms. 4 terms. 4 monomials. Very good. Very good. Perfect. All right. So, first is 28 square root of 12. Outer is 21 square root of 24. Y'all okay so far? Okay. Inner is negative 12 square root of 18. Last, negative 9 square root of 36. Very good. Now you can finally say 36, Scotty. All right, now unfortunately, this one's a little ugly because every single one of them can either be broken down or it's a perfect square. What about 12? 4 times 3. Now, this is a good time where if you can bring out that 4 as 2 in the front, it's going to save you some time and some energy. I'm going to write it down for people that can't do that yet, okay? All right, what about 24? 4 times 6. Very good. Why did I not use 8 and 3? 8 is on perfect square, Grace. Perfect. All right, right about 18. 9 times 2, good. There we go. What about 36? 6, good. Everybody good? All right, what about this? I can take out, can we do this in our heads? Or do I need to write this step down? Hold. What's the square root of 4?
2.
2 times 28 is? Use your calculator if you need to.
No.
No.
Wait, what?
I got that.
What's wrong? What's wrong? D?
Where'd you get your 6?
Square root of 36. Perfect square.
Oh.
Is that your question too, Leonella?
Yeah.
Yeah, it was just a perfect square. Was all. Everybody okay? Okay, what's the square root of 4? 2. And what's 2 times 28, Matthew? 56. Alright, what's the square root of 4 again? Bless you. 2. And then 2 times 21 is? 42. Square root of 6. What's the square root of 9? 3. What's 3 times 12? Negative 36. Square root of 2. And this one is just 9 times 6? 54. There you go. Nothing has the same square root, unfortunately. So that's my answer. Are y'all okay? Alright. Let's move on to the bottom. Now, dividing radicals is the same as rationalizing the denominator. What is wrong about all 3 of these problems? They both have square root on, all 3 have a square root on the bottom. Now, these are different than yesterday. Why are these different than yesterday?
Because it's more than just.
There you go. You have to multiply by the conjugates. What is a conjugate? What do you mean by the opposite?
It would be square root of 5 plus 4.
It's the opposite sign. Very good. So you're going to do the opposite sign, which is the square root of 5 plus 1, okay? Now look, make sure you understand that that 1 is not under that radical, okay? Now, if you need to, all we're going to do is smush them. We're not going to do any math. We're just going to smush them together. 2 parentheses square root of 5 plus 1. Because some people need to do this. And then square root of 5 minus 1 with parentheses, square root of 5 plus 1. Are y'all okay? Do you see how much prettier that looks? It's easier to see. It's easier to read. Distribute the 2. This is just going to be 2 square root of 5. Because they're not like. Plus 2 times 1 is 2. Are y'all okay? What was the beautiful thing about conjugates?
It's like the middle 2 cancel out, so you only do versus.
Perfect, Gracie. The middle 2 cancel out. Outer and the inner cancel out. So you only have to multiply the first, which is square root of 5 times square root of 5, which is square root of 25. And the last, negative 1 times positive 1, is negative 1. So square root of 25 is 5 minus 1.
Wait, what? Where did you get the negative 1? I'm sorry, I lost.
What, baby? Well, hold on, wait.
Where did you get the negative 1?
The last, negative 1 times positive 1, is negative 1. See, when they're conjugates, you only have to do first and last. All right, what do you notice about all of those numbers that do not have square roots? They're all multiples of 2. It has to go into all of them. So all of them can be divided by 2, which would be 1 square root of 5, or just square root of 5, plus 1 over 2. Are y'all okay? Okay. Let's finish out 2 and 3. Tomorrow we will go over our test, because they're ready right now for you, but we just don't have time today. What? You didn't have to distribute if you don't want to. It won't always work, though.
No, I'm saying all you gotta do is flip the whole problem and add a plus sign.
You're not flipping the problem. You're only multiplying by the bottom on top and bottom. I never multiplied by 2 anywhere.
I know, but he's saying
It's a coincidence.
Yeah.
It's a coincidence. All right, here we go. So this one's, I'm going to do the conjugate. What's the conjugate?
The opposite sign.
Opposite sign. So square root of 3 plus square root of 2. And square root of 3 plus square root of 2. I'm not going to do any math to start with. I'm just going to smush them together, okay? Y'all okay so far? Do y'all want to wait and distribute the 6 at the end in case it doesn't?
Sure.
In case it doesn't go.
Let's just do what we do.
Okay. All right. Well, let's keep going then. Okay. Gracie, if you don't want to distribute, you know how to do it. Okay. So let's see. That'll be 6 square root of 3 plus 6 square root of 2. And oh my goodness, these are conjugates, so I'll only have to multiply the first and the last. First would be square root of 9, which is just 3. Last is negative square root of 4, which is just negative 2. And 3 minus 2 is how much? 1. Put it back in the tray for me. Thank you, sir. And I don't have to write the 1 on the bottom. So that's just my answer. Y'all okay? This is literally an Algebra 1 problem. These are not Algebra 2 problems. These are Algebra 1 problems. Yes, ma'am.
So could you just leave, would you have to distribute the 6? Or could
No, you could leave it on the outside if you wanted to. It's just, again, one of those things you just have to see how they give you your answer. They're more than likely gonna, they usually leave it factored out because it's less ink. So, all right, here we go. Number three, last one. Here we go. Let's see. Let's multiply by what?
Whoa.
Whoa, what?
You're not gonna do 9 minus 2?
Can I?
No, please.
Oh, that's what.
Mm-hmm. It's going to be multiplied. So it'll be square root of 3 minus 6. Square root of 3 minus 6. First step, no math whatsoever. You're just going to smush them. Y'all okay? Okay, now the top is a little funky because you got to do what? Well, there's a fancy way to distribute. Foil, right? Foiling is a fancy way to distribute. How do I know to foil? Because how many terms are there? 4, right? Okay, so here we go. First is going to be 9 square root of 3. Outer is negative 54. Inner, negative 2 square root of 9, which if you can do that, that's negative 2 times 3, which is negative 6. Last is negative 12 square root of 3. Did I lose anyone? Where? Yes, excuse me. Thank you, Dee. Okay, last, they are on the bottom, they are conjugates. So I'll only have to do first and last, which is square root of 9 minus square root of 36. Okay, so we have, okay, look at what we have.
Why is it the square root of 36?
Is it not a square root? Oh, it's just a 6. I didn't even see that. Golly. Dang, gotta pay attention. Did not even see. I was assuming they had the square roots. All right, so look what we got. We got like terms right here, right? Because they both have square roots of 3. What's 9 plus 12? 21, square root of 3. Minus, okay. So right here, let's do this in steps for people, but some people need it in steps, okay? Square root of 9 is 3, but yes, it is negative 60. And then square root of 9 is 3 minus 36. Are y'all okay? All right, so now, what? Let me write it in steps. 2 times 3 is 6. 3 minus 36 is negative 33. And that's 21 square root of 3 minus 60.
You can take out a 3.
Oh, dang. I noticed that as soon as I started circling. Yep, you can. They're all divisible by 3. So that'll be 7 square root of 3 minus 20.
Wait, you can take out a negative?
Nope. Well, you could just stick this negative in the front if you want to, because that's where it's going to be whenever you see it on a test. And then that'll be negative 11 on the bottom. That'll be your answer. That negative is going to be stuck out to the front. All right, so listen up real quick. Here's what we got. I'm going to come around and check your homework. We're going to go over number 2 tomorrow, okay? We're going to go over number 2 tomorrow. Tomorrow, what we're going to do is we have 3 different checkpoints that we're going to do in class before we move on, okay? Because I know this is a lot of information. Most of it is a review from Algebra 1, which is why there's so much. Second thing we're going to do tomorrow is we're going to hand back your tests and go over all of the questions on the test, okay? They're already graded in the computer. So if you need to have yours, if you need to come this afternoon so you can go over yours with us tomorrow, then that's fine. If not, then you can just take yours tomorrow morning during zero period if you still need to take your test and go from there, okay? Are y'all good? What did I just say?
Tomorrow.
We don't have enough time. We took too much time on the ACT stuff. We don't have time to do it right now. We'll do it tomorrow, okay? I promise. It'll be the first thing we do tomorrow.
2 was really hard.
It's just a little different. There's a different way you have to work it since it's odd.
Yeah, I didn't know that.
All right, homework. Grab your homework real quick. Let me see it. Homework, homework, homework. Let's do this. Let's bring it to me since I got all the stuff in my grade book. Let me pause this video real quick. All right.